Hello students, welcome to Sarasa classes. In this video, I'll be solving some subjective questions from the book Tomato. Now, in this question, there is a certain game in which there are 30 balls of k different colors and they are kept inside a sealed box. We are only told the value of k but not the number of balls of each color. And we have to guess whether it is possible to split these 30 balls into 10 different groups of 3 each, such that each ball in this group is of different color. You are to answer with simple yes and no, and you will win if your answer is correct, otherwise you will lose. Here we have to find for what value of k we can answer no, and for what value of k we can say yes. If k is 1 or 2, the answer is obviously a big no. However, if we have k equals to 3, then each color of ball will be 10 in number. So it is possible that one box can have 3 different types of color ball. So no is not a sure winning. Now for sure shot yes, we have to have k greater than equals to 21, because if k is 21, then if a single type of ball is 11 in number, suppose a single type of ball is 11 in number, then the resulting 11 in number that may cause duplicacy of 2 balls of same color, then the remaining number of balls is 19, and the number of that is 30 minus 11, and the number of remaining types is 21 minus 1, which is 20. Now 19 balls cannot be of 20 colors. So if k is greater than equals to 25, there is surely a 3 different types of balls in a single box. However, if k is equals to 20, then it is possible to have 11 balls of same color, because 20 minus 11 is 19. 19 balls can be of 19 types. That is 20 minus 1 again. So for 20 balls, we cannot be certain that each box will have 3 different colors. In our next question, we are given a set S is equals to x comma y, where x and y are non-negative integers less than equals to n. Now, we have to find the number of squares that can be formed with vertices belonging to S and sides parallel to the axis. Now, this is axis. So for sides parallel to the axis, the boxes has to be like, I'm changing the color here, like this, or like this, something like this. So the number of squares with sides of unit length, yani when length would be 1, is n into n, that is n squares. Now the number of squares with length as 2 units will be n minus 1 into n minus 1, which is equals to n minus 1 square, and it will go so on. So the total number of squares will be n square plus n minus 1 square plus and so on till 2 square plus 1 square, which is equals to n into n plus 1 into 2n plus 1 divided by 6. In our next question, we have set S, that is the set of all integers between 1000 to 999. Now, the two integers x and y in S are said to be of equivalence class if the digits appearing in x and y are same. For example, here x has digits 1 and 0 and y also have digits 1 and 0, so they are in same equivalence class. But z has 0, 1 and 2, so z is not in the equivalence class with x or y. Here we have to find the number of distinct equivalence classes that can be formed out of S. Now, if A is a member of some equivalence class, then its distinct digit can be determined by the equivalence class. That is, if A is a member of some equivalence class, then its distinct digit determine the equivalence class completing. Hence, the number of equivalence classes that are there is given by the number of ways in which I integers can be selected from the group 1, 0, 1, 2 till 9 for I which is less than is equals to 5 and greater than equals to 2, and for I is equals to 1 it has to be selected from 1 to till 9. So this can be done in 9 plus summation I is equals to 2 to 5. From here 10 Ci which is equals to summation I is equals to 1 to 5 10 Ci minus 1.